Hello, everybody, and welcome to the first joint webinar of CoreTigo and VAHLE. Today, we are very excited to present to you our latest breakthrough communication and power technologies for independent card systems. My name is Johannes Schipflinger. I am product manager for contactless power supply systems at VAHLE, and I'm proud to show our contactless technology today. At first, I want to shortly introduce VAHLE. So if you're looking for control systems, guided communication, optical or magnetical positioning systems, or last but not least, conductive and contactless power supply, VAHLE is providing the system solution for you. Now I want to give the word to my colleague Ohad from CoreTigo.
Hey, my name is Ohad. I'm head of product marketing at CoreTigo. CoreTigo is a company that provides wireless industrial solutions, focusing on solutions based on the IO-Link wireless technology. And today we're going to talk together with VAHLE about the added value that both power and wireless communication can add to transport track systems. But before we go about doing this, we need to overview what are transport track solutions. We're going to review transport track solutions, talk about the advantages of them, and then we're going to talk about the challenge of transport tracks in becoming a truly effective and fully productive systems in the factory. And a little spoiler here, but we're going to talk about how contactless power can add, along with wireless communication, to the transport track value, overall value for the production line. And then we're going to talk about what are the benefits of doing that, and about the adaptive machine, and about manufacturing in motion and the overall value.
So today, as Ohad mentioned, we are talking about flexible production technology and transport tracks. But what exactly do we understand as a transport track? Did you ever hear about maglev or for example, transfer bit trains? I think so. The connection between them and the flexible transport tracks is the drive technology. They are both driven by a linear motor. At a linear motor, each vehicle, in our case, they are called shuttle or mover, can be controlled individually, and they are driven from the stationary sides. This results in many advantages of this technology.
So overall, if in the past, production used to be done by moving things around using conveyor belts, now transport tracks are adding a whole new dimension to the flexibility and agility, and also to the speed of doing things. First of all, as Johannes mentioned, most of transport tracks are magnetically propulsed, so that means fewer parts, fewer energy consumption for moving objects around the factory, and much better motion control, faster speed, and all of that actually comes at less cost because there's less wear and tear to the system because of the magnetic nature of it. Once you're using transport tracks, you can increase your efficiency and flexibility in the production line, especially when you're trying to do line changeovers, when it comes to mass customization, when you're trying to produce more than one SKU in a production line. That means you can do smaller batches, you can do individualized products, and because each unit in motion does not depend on the unit before it or the unit after it, in line, you can actually reduce the bottlenecks because you can plan production in a much more efficient way. And also because this is, again, something we're going to talk about later on, but because you can actually do production or some of the production while in motion, you can actually have a much more efficient floor plan using transport track system linear motors. So a lot of manufacturers are starting to deploy this type of technology and offering solutions, a variety of solutions, ranging from very small ones that are being used locally for local manufacturing, all the way through large transport tracks that are being used for automotives that can carry high loads. You can see a solution here by Beckhoff, by Rockwell Automation, by B&R, by Bosch, and there's a variety of manufacturers now targeting the market all the way from Canada to China and Japan. There are many applications that can be done using that.
So the types of application for these linear motors are nearly unlimited. There are use cases, for example, I want to introduce you, for example, in the packaging industry. By the way, this was the first to be equipped together with data and power on the mover. The linear motor systems are also used for food and beverage production. As an example here, there is beer production. And also for the automotive industry, due to the change to a sustainable mobility, it is also used in battery production, but also in normal car production. For pharma and cosmetics industry, with its enormous variety of stock keeping units, this technology is also a huge step to more flexible and efficient production. Last but not least, also intralogistics companies are using transport tracks to move and sort goods. The use cases don't end here. There are even new applications and possibilities due to new and creative system design possible by this technology.
So this independent motion that allows you all these applications is great. It's a very novel thing and a lot of adoption in the production lines, but it comes at a cost. All this independent motion, all this ability to move things around independently on movers, on shuttles, actually means that you have a problem to connect them to cables, because once the shuttles start to move, there's no option to connect them and to have communication and power while on the go. So if you cannot have onboard power and you cannot do monitoring and you cannot do control, all you're left is a glorified piece of metal that is moving around the factory. So you got motion, but this independent motion actually, by its nature, limits the range of applications that you can do with it. Now, don't forget that this is not a conveyor belt. This is a sophisticated system with magnetic propulsion. It comes at a cost, and it's a very advanced manufacturing functionality, and customers and manufacturers that are deploying these type of solutions actually expect more return on investment and more applications, and they would like to be able to do a lot more than just move things around. Because when you're moving objects around, but you're still doing the manufacturing at a fixed place, then you need all this external robotics. You need to move things to a specific station in the way, and there's a very big limitation. Now, there are issues in providing power to a moving object, and there are also issues in providing communication, monitoring, and control to an industrial environment that requires very low latency and very high reliability. And this is exactly the points that we're going to address in this presentation with solutions by VAHLE and by CoreTigo. So now Johannes is going to talk about the contactless power solution by VAHLE.
So as we have learned, cables are not an option for this type of application. I want to start the introduction of the VAHLE system, of the contactless power supply system of VAHLE, with a linear motor equipped with the contactless power supply system. So as you can see, one mover is equipped with an additional device called pickup. The pickup is the moving mobile unit of the VAHLE system. Below the pickup, there is a 2-cable track going all around the linear motors with different types of mounting material and cables supplied. This track is supplied by a primary power unit, which is the stationary device supply system for the contactless power. The function principle behind that is that the primary power unit converts the net supply voltage, which could be 50 or 60 hertz or 380 to 480 volt AC, to a 140 kilohertz, 45 amps current source. This current is then flowing through the 2-cable track below the pickup. The track emits a defined magnetic field, which is picked up by the pickup. That's also where the name comes from. And then it is converted to a usable 24 volt DC supply voltage for sensors, actuators, or even the communication devices of CoreTigo. So that's all you need for a functioning VAHLE contactless power supply system. There is one more thing. By adding additional worker units, it is possible to control up to 12 segments via your PLC and via the field bus communication like Profinet or Ethernet, and start and stop the system. Let's go back to the pickup unit. VAHLE offers two different types of pickups for this application. On the picture, you can see a short track, which you can see here, with both pickups added. On the left side is the one we have seen before. It is called U015. This is a bigger one, which is used for power-intensive applications and with more payload. On the right side, there is the small brother, the so-called U007 pickup. This is the most compact and lightweight version on the market. So let me describe the challenges and characteristics of these pickups. The first and most important challenge is that the pickups are contactless. They don't have any wearing parts, and this results into no maintenance and unlimited velocity. Also, the pickups are continuously supplying the application as long as they are in an area equipped with the track. VAHLE's pickups are the most lightweight on the market and fit even the narrowest shuttles with a pitch length less than 40 millimeters. I want to give you a few facts about the pickups. The U007 pickup on the right only weighs 175 grams, but still delivers a power of 70 watt. The big brother U015 is capable of 150 watt. Both are supplying 24 volt DC. They can be operated together on the same track and are both rated to IP65 with more to come at the smaller one. So now I want to give the word to Ohad to explain the CoreTigo technology.
So now that we established that we can actually get power on top of the moving shuttles, what we're missing is communication. Now, communication is for all kinds of data, mainly for monitoring, getting data out and from sensors, and for actuators that will allow you to do actual automation on top of the shuttles. Now, there are many wireless technologies out there, but none of them was originally designed for industrial applications. So if you're looking at Wi-Fi, or you're looking at Bluetooth, or sometimes people are trying to do things with Zigbee or proprietary technologies, there were consumer electronics or general purpose wireless technologies that are being adapted into the industrial world, and they're lacking. What is missing is a technology, wireless technology, that is actually designed for industrial applications. And then comes IO-Link Wireless. IO-Link Wireless, which is at the core of CoreTigo's solution, is an extension of the IO-Link, the famous IO-Link's global communication standard. This is the wireless version of it, and it's part of the standard itself. It was designed for industrial applications with the mindset of keeping things very, very reliable and predictable and deterministic. So IO-Link Wireless is, besides being a universal standard, is a very fast standard, very fast technology that allows low latency of 5 milliseconds, which is a latency that will allow you to do actual production, actual automation, actual control, and not just monitoring. It is literally 1,000,000 times better than any other wireless technology that is being used right now on the market, like Wi-Fi or Zigbee. That means 6 orders of magnitude less packet error rate. It's a deterministic protocol, and it is noise resistant and can coexist with other wireless networks, and it's scalable. So using IO-Link Wireless solutions by CoreTigo will actually allow you to operate or to monitor hundreds of devices in the same work cell, in the same work area, or on the same machine. So very high scale, which is very important for applications like transport tracks, where you have multiple shuttles running on the same track with both monitoring and control needs. So the bottom line of IO-Link Wireless is that what you're getting using it is a cable grade communication, but without the cable in a wireless fashion. So how does it work on a transport track? Here you see a sample of a transport track. What we have all around it is a radiating cable that allows connectivity throughout the track. Over here, what you're seeing is the Tigo Hub i4. The Tigo Hub i4 is a device connectivity unit that is being assembled on the shuttle, on each of the shuttles. Means that you can actually, with a link wireless reliable technology, not just get data from sensors that are mounted on top of the shuttles, but you can actually operate actuators. You can actually do real-time automation. You can control pumps. You can control grippers with a low latency and real-time automation level. And the way it is connected is through a near-field antenna that you can see here. The near-field antenna is actually designed specifically for the transport track application, making use of VAHLE and wireless in a much more reliable and secured way, because here the transmission length is about 1 or 2 centimeters away from the radiated cable. It's contactless, it's wireless, but it allows shuttles to run all along the tracks without losing connectivity, and it doesn't have to be localized to a certain area. It can be throughout the factory. It's very similar to the way the VAHLE pickup that you can see here in number 5 is not touching their rail and providing inductive power. We're providing wireless connectivity. So once you get this wireless connectivity transmitting and it being picked up over the radiated cable is connected to a Tigo master. Tigo master receives the data from these hundreds of devices that are around. You can have up to 5 Tigo masters connected to the same radiated cable. Each of them can support 12 different wireless links. So you can have literally hundreds of devices on the same track. And the Tigo master takes the data and connects it to a PLC for automation purposes over common industrial Ethernet protocols such as Ethernet IP or Profinet or EtherCAT, and also over OPC UA. And at the same time, the same Tigo master can communicate information northbound to industrial IoT applications over MQTT or OPC UA, and it can connect to the ERP or MES systems of the factory, or it can send stuff for the cloud for monitoring or for even predictive maintenance. In addition, you have the Tigo engine, that is the engineering tool that allows you to configure this entire network, but it is much more than that, because what it can do is actually parse the process data, convert it to secure MQTT, serve as a data platform of its own. But in general, what you have is hundreds of devices in a reliable fashion that will actually allow you not only to transport units, production units around the factory or around the production line, but actually do automation on the move, which brings us to the next topic. So how do you do manufacturing in motion?
We are combining now data transmission from CoreTigo and power supply from VAHLE, and we get with this the adaptive machine. On the right top corner of this slide, you can see a conventional filling machine, which is inlay is especially designed for one kind of glass or can filling. To change from one glass size to another one, this machine has to be stopped and the inlay has to be changed manually. Now, with our technologies, we are enabling smart machines which can adapt to new containers by something like a mouse click. Ohad, can you please explain the advantages?
Yeah. So basically, even here in this image on the right-hand corner on the top, it's still a transport track, but it can only move things around. But when you convert this into a transport track that is power and communication enabled, you can actually perform actions while in motion. So you can sort these cans out, you can package them in different carton containers, different sizes, different SKUs, And you don't have to stop the machine in order to do that. All you need to do is update the software. You don't have to replace parts. You don't have to adjust the physical mechanics of the machine. It allows you to do things while in motion, and that way you can produce on the same production line, you can produce a wide range of package variations. You can adjust to size, to weight, to shape, to styles, to printing, all in a single machine. You don't have to stop the machine for changeover, just for parameter adjustments, and there you go. You can continue doing stuff on the same production line with minimal setup time between different SKUs. This way, you also reduce the cost and you reduce your time to market when you need to do mass customization, when you need to change in between designs, when you need to adapt for variations in materials and in products. Because you can also do the production on the line, you don't just ship the units for production under different stations, but you can actually do stuff on the move. You reduce the footprint of the machine. You don't have to move things and have external robotics. You can have the robotics on top of the same platform. And this means that a lot of your things in motion can actually do the actual production without these external robotics. And the fact that you can have sensors on board the units, both on the units themselves and in the production, means that you can also get the data, send the data to a central place, and run predictive maintenance algorithm on it. When you have predictive maintenance, not only do you save time for changeovers, but you also save time for unplanned downtime and maintenance because you got the predictive maintenance features with the data. All this leads to a brand new approach to manufacturing, because you don't need to choose now between mass production and mass customization. You get capacity and flexibility all in one machine and on the same platform. And this is a real game changer in the real world. So now this brings us to the end of this presentation, and we're ready to take questions from the audience. There's a Q&A section in your platform, and you can ask questions. I see we already have some.
Yeah, so there's a few questions here, Johannes and Ohad. First question is, when you're measuring when you're saying 1 million times better than every other radio technology, in which parameter are you measuring it for VAHLE Wireless?
Okay, so good question. There's a concept called packet error rate. Packet error rate is how many packets passed without, how many packets failed over a large number of packet error rates. And actually the standard packet error rate for Wi-Fi or for Bluetooth is around 10 to the 3. And with CoreTigo, the packet error rate is lower than 10 to the minus 3, sorry. And with CoreTigo, with VAHLE Wireless, actually, it's 10 to the minus 9, which means it's literally 1 million times better than these other protocols. And it's very close. It's pretty much the same as the packet error that you get on an actual cable.
Okay, thank you. Next question is, what type of data is transmitted or can be transmitted, like sensor data in the example of the adaptive machine with the adaptivity on the movers? Okay.
What type of data is basically every data that is related to production or to monitoring. So everything that can be transmitted over IO-Link can be transmitted over VAHLE Wireless. And that means that you can get both control and control actuators, but it also means that you don't just get the one bit of data that controls, for example, grippers saying close or open. You can actually say by how much do you want to close or open and get other sensor information at the same time.
Okay, thank you. Johannes, a question for you here from the audience. When you mount the pickup module on the shuttle, does it increase the payload and thus impacting on the performance of the motion? Do you have any experience with that?
We from VAHLE, we have designed the most lightweight pickups with only 175 grams. So for sure, this is added payload on the mover, but with this low amount of weight, the impact is not that big. That's what we have learned.
Okay, thank you. Next question is related to interferences and noise. How does the system, I guess this is related both to the VAHLE system and the CoreTigo system, how does the system or the solution deal with noise and other wireless networks interferences?
Okay, I can answer on the side of iLink Wireless. iLink Wireless was designed to coexist with other wireless solutions in the same environment. So there's a hopping mechanism and there's a redundancy mechanism, and it's very deterministic. And when we're talking about the reliability of the system, it was measured not in vacuum, but in an actual noisy environment. And it's being deployed right now along with other systems. And don't forget that also the VAHLE system is wireless, it's using magnetic transmission. And because we coexist in a very close proximity, it shows very high reliability. We're even transmitting inside CNC machines that are rotating at 6,000 RPMs and no issues and no interferences, not from the motors and not from other wireless technologies around.
Also same for the VAHLE system, as we are at a completely different frequency, we are also not disturbed by any other communication technology.
Okay, and I think last question I have here, at least for now, is apart from packaging, what other applications can such transport track systems be used for?
Okay, so we went over the slide. Johannes showed the slide with all the different applications, but we're actually, CoreTigo and VAHLE met during a joint project. And since then, we're doing a lot of more projects and we're getting some design wins in the market. And the amount of applications are really surprising because you got it anywhere from large logistics centers where the lines are running across, moving packages around, all the way to actually small systems that are replacing robots. But instead of having one robotic arm taking stuff on one end and putting it on the other, you actually have tens of them running really, really fast on the same transport track system and just doing all these actions and not stopping the production lines. So there are many limitless applications, literally, as Johannes said, and we're seeing a lot of them in the market. Johannes, do you have?
Yeah, I can just continue to this. We have met in the market, and yeah, we are doing projects together also for pharma industry, for food and beverage, and that's so every application can be fit with this linear motors and with our systems.
Mm-hmm. Okay, thanks. Actually, one more question here. Johannes, regarding the power, what are the limitations of power, assuming 24-volt DC and current accordingly that's available on the shuttle? And are there any other voltages available, for example, 48-volt DC?
Yeah, for example, so let me describe the first question with 24-volt. So the smaller pickup has 70 watt, it's 3 amps, and the bigger one has 150 watt, is like 6 amps at 24-volt. Also, if there is a need for 48-volt, it is possible to switch the pickups in series, that you get, for example, 2 smaller pickups and have 48-volt. That's the possibility. And from the primary side, we have systems up to 30 kilowatt. So that means in one segment, you can have up to 420 pickups. So basically no limits on this.
Mm-hmm. Okay, and I think there's one more administrative question here. Some folks are asking about these slides, whether they can be distributed further. Both the slides and the recording of the webinar will be provided to the attendees and the registrants. Okay, so Johannes and Ohad, any last comments?
Now, you see, you have our contact information here on the screen. So if there are any questions that were not answered, please feel free to contact us directly, whether it is to VAHLE or to CoreTigo or together.
Thank you for the attendance and have a nice day.
Thanks, everybody.